Hi everyone, there is Maggie from Awesome Tuts, and in this video we'll create a brick breaker game in Unity. So that is another Android game for Android devices. So when I go here in File and then Build Settings, you see that current platform is this PC, Mac and Linux standalone, and this is one default platform. Whenever we create a new project, this is the default platform of our project. So if we want actually to create an Android game for Android devices, we definitely need to choose here an Android and then switch platform. So I will simply go here and click to the Android, and we need to click here on switch platform in order to our platform now be the Android. And this can take a while, so you just need to take a cup of tea and wait a little bit in order to your Android platform be optimized for your game. And once our game is for Android optimized, now we can, for example, you can later on when you create all game, you can, for example, build this and run in your Android device, or you can easily download the Unity remote app. That's very cool app that Unity Technologies provides to us, and you can also test your game on your Android device by using this app on your phone. And that was that for this Android optimization. So this is also one new Android games. And then I want also to show you that for the resolution we will use, so you see how much we have there our resolution for our game. But I think this simple HD landscape resolution will be enough for our game, will be perfect resolution for our game. So simply choose that simple HD resolution landscape and you are good to go if you want to follow this tutorial. Okay, now we can start with develop our game. So we'll go here and I import there a bunch of assets and prefabs. So when I go to the assets, we see that we have ball, blocks, pedal, signboard, wall, and so on and so forth. But instead of importing these and attaching the components on these assets, I simply created a prefabs. Also, you can download with the link these prefabs and assets and so on and so forth, instead of boring yourself with creating these assets, with positioning these assets and attaching components and so on and so on. So I create and prepare this asset just for that problem. So now we can easily drag and drop this in the scene. This is everything, there is everything prepared. So when we, for example, go in bricks level 1, and when we open this prefab, we see that we have there a level 1 full functional level 1 scene. And as I said, we can now this easily drag and drop to our scene. So I will go back here and I will simply drag and drop this right to our scene and we are good to go. So I will simply position here somewhere in the center like this, and I think we are good to go, guys. So now we import our level 1 and you see how easy this was. You also have there a level 2 and level 3 that I also prepared for you, and that was that. Okay, now one more thing that we need to import here is our walls. So when I go here in walls UI, you see that I also prepared this wall. So when we drag and drop this, you see how awesome this is. So when we go in the game, we'll see this, and we need of course to optimize this a little bit. So we need to position this well. And also one more thing that we need to import along with these walls is going here in the assets and searching for the sign. I think that, yeah, this is the signboard and this is actually our road down here. So we need to drag and drop this also to the scene. We don't need to compress this on some specific way. We simply need to drag and drop this in the scene and we are good to go. But this time this signboard actually will have one component, and that is of course our box collider 2D, because when I ball go behind or below our pedal, we will destroy that ball and we lose the game. Or actually when our ball touch our signboard, that's of course below our pedal, we will simply lose our game and we will simply destroy our ball. Okay, this is that box collider 2D. So everything I think is very snapped here, very well snapped. So of course a little bit move down here, and also we will go here in the main camera, and for the background color we will choose that we want completely black color. So when we go in the game we will see this, but we will also have, don't worry, we will have a background behind this level 1 and these walls and so on and so forth. So we'll go here in the backgrounds, and I import here a couple of backgrounds, so you can also download this via the link in the description. So I think, and I found that this background, so where is that background? Yeah, this is the wind background. I think this background is very nice for the beginning, but you can choose a background on your own. So background that you like, you can choose here, and I will a little bit resize this background, for example like this one here. So snap a little bit this background in fine order. When we go in the game, we will see this, and guys, I'm satisfied with this. But also we need to go here and choose our level, and I think that we need a little bit to move up this level. So like this, just these bricks, these gray bricks here, to go in just this angle, to be positioned and snapped well to these angles. Yeah, like this. And I think this is the fine. So a little bit more here, just a little bit here on the left side, and yeah, I am satisfied with this, guys. So now, two rest game objects that we also need to import here is our ball and our paddle, of course. So we'll go here in the prefabs, and we will, of course, like our level and all of these game objects, we will drag and drop our paddle. And you see that in this paddle we have a couple of components. So we have a rigid body that is put to be kinematic, so don't forget to put this rigid body to be kinematic, otherwise this will not work. And polygon collider 2D, which is the one simple collider, like our boxer and circle colliders. This is just the polygon collider. Everything is the same, just the shape is different. Okay, now we need also to drag and drop our last game object, that's our ball. And you see that also our ball, so we see that we are missing one script. We will remove this quickly. Also have this rigid body, but this time this rigid body is dynamic instead of kinematic, like for the paddle case. And we have, of course, circle collider, because this is the ball. We need to have a circle collider around him. Okay, now it is time for coding. So now we'll go here in our scripts folder that I also create, and go and create new C# script, which is going to be a paddle. So first thing that we need to code in this game is our paddle. And of course we will open it up in Visual Studio. And when we are in our script, we will start this with creating a couple of variables. So first variable will be private, and then float. And then this will be mouse position, so mouse position in blocks units, so in blocks units. Then second variable will be also private float, but this time this will be a force, which is going to be by default put it to 7000 F. So you can add here an F, and we give a default value to this variable. Okay, moving on, now we need to create a private vector tree, so vector tree, and then this will be a paddle position like this, and also private rigid body 2D, so rigid body 2D, which is going to be, of course, all our paddle RB, so the rigid body of our paddle. And now we need to create three serialized field variables. If you don't know what is a serialized field variables, I will explain this in a second. So first one, I will create this serialized field in these square brackets, and down below we are going to pass a regular variable that is going to be private float, and first one will be minimum position, which is going to be 1.84 by default, so we will add here an F. And now I will take this variable and copy and paste these 2 times. And second actually variable will be also private float, but this time this will be a maximum position instead of minimum. And for the third variable, this will be a screen width in blocks units like this. And of course we will change their values, so there will be for the maximum position 14.14 F, and for the screen within block units there will be 16. And that was that guy for our variables. Now we are going here, instead of start method, we are going here to create a wait method. So this is very same method, but one difference between these two methods is that awake just is called one frame before our start, so just it is called before our start a little bit, and everything stays the same. Okay, for in the awake function also we can initialize our variables like in the start function, so we will add here a pedal RB. So pedal RB, it is equal to get component. So get component in the angular brackets, we'll add a rigid body 2D, parentheses and semicolon. For our paddle position, so paddle, yeah, there is our position. This is going to be equal on new vector 3. So new vector 3, and in the parentheses transform dot local position dot x. So local, so there is local position dot x, and also transform dot position dot. So no, just the position, I made a mistake again. So there is a local position dot y and z. We do not want to touch this. This remains at 0. And guys, we are good to go. So that was that for the awake function. Now we are going actually to create one new function on our own, and that is void play. So void play function, and in this function we are going to program the moving of our paddle. So we are going to use our mouse position in blocks units variable, and in that variable we are going to store in double parentheses. So we are going to pass here input dot mouse position dot x, and then we are going to divide that with our screen width. So this screen and dot width, and of course we are going to multiply that with our screen width. So screen width in blocks units variable value. So now semicolon, and then new line of code will be our paddle position. So paddle position dot x, and this will be equal to, so I'll pass here equal mat f dot clamp, and in the parentheses we are going to again use our mouse position in block units, and that was for the first parameter for the float value. For the second parameter, which is a float minimum and float maximum, we are going to add here a minimum position that we have created right above, and for the third parameter, which is the float maximum, we are going to add here a maximum position of our paddle. So now that was that, and then last line of code in this function is our transform dot local position is equal to paddle position. And what we did here, so first we initialize variables in the awake function. That's very similar to start function, but it is called one frame before start function. And we actually initialize our rigid body variable from our paddle and our paddle position. And then in the play function we use our mouse position in blocks units, and then store that in our actual mouse position on the x-axis divided in the screen width, and then multiply that with screen width in block units. And actually we then use our paddle position, so current position of our paddle.x, and store that in mat.clamp, which simply takes 3 parameters, and you see here that takes float value, float minimum, and float maximum. And the float value, first one, is our mouse position. So where our mouse is, there will be our paddle position. And then we actually need to provide a minimum position where our mouse is able to go, where our paddle is able to go, and that is minimum position that we provide here. You need to find a position that is acceptable for your game, for your project, if you follow this tutorial. And the same way, maximum position is where our mouse can go, where our mouse is able to go, or our paddle is able to go, and that is our screen. And then on the last thing, actually we store that back, so transform.local position of our paddle. So this is the paddle script, and transform.local position is our paddle transform.local position. We store that back to our paddle position that we have just coded here. And that was that. For the last thing, we need to call this play function in our update method, and we are good to go. So now I will save this and go back to the Unity. And before every testing, of course, we need to attach this paddle script on our paddle. So we'll go here in the add component and searching for the paddle script. And now we attach that script, and we see that there are variable values that we have created before in this script. So minimum position is these values here. And that was that. So now we are able to test this out. So I will go here and play our game. And it seems that we give a very, very wrong variable values. So actually for the minimum position, I found that the perfect value here is a -6.14, and for the maximum position it will be actually in positive +6, and then 15 or 16, add here whichever you want, and I think this will fix the problem. So we will test this out one more time, and now we will try to move here, but now we see that everything is fine. So now we can move just our paddle in this area of our camera, in the area of our gameplay scene. So this is very fine. So there for the left side, so the end dot is minus 6.14 and the positive dot is 6.16, and we cannot move our paddle anymore after these variable values in the left and the right side, and this is very fine. But we need actually to fix that. Whenever we play our game, we will actually make that our ball follow our paddle in the beginning of the game, and you will see that this is not some error or problem, but it seems that kinda it is, but it is not. So believe me, when we later on program our ball, you will see that everything will be fine. But we will now program the bricks. So we'll go here again in our scripts and create a new script, which is going to be a bricks script. So in this bricks script, we'll have just two variables. One is serialized field, again like in previous case, and then private sprite, and then we'll pass these square brackets, and this means that we are creating array, and then we are going to create an array of our heat sprites, and then semicolon, and second variable will be private integer and then a number, so number of hits, like this, and this is going to be actually the default to 0. So we will give the default value number of hits to be 0. So this is not there is not an f because this is the integer, this is not the float. But I forgot in previous case to explain what does this serialized field means. So this serialized field means that this variable will be visible in the inspector panel, but this will remain private. So actually this is very similar to, for example, when we pass here public. Now this variable will also be visible in the inspector, but in this case this variable remains public. This variable is transferable to other scripts, is simply public variable, so every script can access this variable. But we actually, when we want to this variable stay private, cannot be transferable to any script, but if we want to that script still be visible in the inspector, then we use this serialized field. We will not have this start method because we don't need this method in this script, and we will also delete this update method because this also will not be a necessary method in this script. But we will have one script, and that is public void and then on collision. So simply on collision, pass here on collision, so no enter, just the on collision, and we are good to go. So now we are going to pass here brackets, open the curly brackets, and now we are going to actually call one method here, that is a process hit. So process hit and then parentheses, but we do not yet create this method. Now we are going to create that method. So we'll pass here void and then process hit. We will open the curly brackets, and in this process hit method we are going to pass that number of hits. So number of hits variable is plus plus. And what does this mean? This means that we are increasing this variable value by 1. So whenever we pass here plus plus, this means increase that variable by 1. And moving on, now we are going to create an integer variable which is going to be maximum hits, and then store that in our hitsprite.length. So hitsprite.length plus 1, and we are good to go. Now we are going to open one if statement, and in that if statement we are going to check if our number, so number of hits of course, is greater or equal to maximum hits. So maximum hits, open the curly brackets again, and then we are going to use our deactivating function, which is our GameObject.setActive is equal to false. And now I will explain what does this mean. So we created a number of hits variable right here, and then we increased that variable by 1 in process hit method, and we then created an integer maximum hits variable which we store in our hitsprite.length, and our hitsprite actually is this array right here. So this is how many times we hit some brick. Dot length, this means how many times, plus 1. So if we actually increase that by 1, because we want to pass that number whenever we hit some of our bricks, we are going to increase that by 1, because now our hit sprite is 1, because we kick one of our bricks. And then we are checking here if our number of hits is greater than maximum hits. Our maximum hits is this one right here, so I made a mistake here, is this one right here, that count how many times we hit some of our bricks, and that is currently 1 time. If we kick one of our bricks above 1, we are going to deactivate that brick. And that is whole philosophy about this process hit method. And of course we call that in our own collision method, and our own collision method is responsible for the collisions in this game. And we will have just that one collision. We will have just the collision between our ball and our brick. For that, we use this method that will detect that collision, and that will call this process hit in order to we can destroy our brick whenever we kick with our ball that brick. Okay, now enough talking. I will save this and go back to our Unity editor, and we cannot test this script and this effect because we don't yet create and program our ball. So we actually need to test out this effect, that is the collision between our ball and our bricks, but we cannot yet because we didn't program our ball. But one thing that you need to do here is actually selecting all of these bricks. So all of these bricks from the level 1, selecting them by holding Control and then clicking them, selecting them, and you need to attach on each one this brick script. So on each one this brick, you need to attach this brick script. So that was the thing that you need to do here in order to this can work and in order to you can test this. But now, as I said, we will create a last script in this video, and that is our ball script. So now finally we are going to program our ball. So open it up in our visually cute Visual Studio. First variable will be our private rigid body 2D, which is going to be my body. Simply we will name this variable my body. And then we are going to create a puddle. So actually this is the reference from our puddle script. So private puddle, and then simply we'll name this puddle. And then we are going to create private vector tree. So private vector tree, and this is going to be paddle to ball position. So we are going to simply pass here paddle to ball. And then moving on, we are going to create also a private static bool. So private static boolean variable, which is going to be has started, and this is going to be equal to false by default. And also one more boolean variable, which is going to be collision enabled. So collision enabled like this, and this one will be by default true instead of this has started. And now we are going to create also a couple of serialized field variables that I explained previously what this means. So serialized field, private, then float, and this is going to be x launch force like this. So we can add a force here, and this will be 3f by default. And one more serialized field variable, which is going to be again private float, but this time this is going to be y launch force. So you can imagine this is going to be for the y-axis force, launching force, and that is that, guys. Now in the awake function, so again we will not use this start function, instead we will use awake. That's called before our start. And then we'll delete these comments, of course, because I hate these comments sometimes. Don't know why. Okay, now this paddle, so we'll initialize our variable. So this paddle actually is the reference from our paddle script. So this is simply our paddle. And this is going to be, we are going to initialize this or find this. So find game objects, so no of type including assets. So I made a mistake. This is going to be find object of type. And then in these angular brackets, we are going to pass a paddle script, because this paddle is from our paddle script. And then parentheses, and of course we have this error because we didn't use this find objects of type with angular brackets. So I will pass again, but this time find one with angular brackets, and now our error gone. Now for our rigid body, we are going to also take a reference of get component and then rigid body 2D. then semicolon, and we are done also with that. Now we are going to initialize our paddle to ball position. So this is going to be transform dot local position, so local position, and then this is going to be minus or subtract with our paddle dot transform dot position, so no position but local position, excuse me, so local position. And that was that for the paddle to ball position. And then has started boolean variable will be equal to false. Everything is fine, we initialize our variables. But now in our update method we are going to check in one if statement if we hasn't started yet. So actually this, when we add this exclamation mark behind some variable, this means if we are not started. So if we, for example, remove this exclamation mark, this means if we started, if this variable is true. But when we add exclamation mark, this means if this variable is false, if we are not started. And that was the difference between this exclamation mark and the variable without exclamation mark. So if we are not started, we are going to call one. So no, that man, I made mistake again. So we are going to call this init function if this statement is true, if we are not started. But we didn't create yet this init, so don't worry about that. We are moving on with our functions. And now we are going to create on collision. So on collision enter 2D, and then this function is responsible for the collisions, of course. So for the collision between two game objects, that is set to be not trigger. So now we are going to use our bricks script, and we are going to create one variable from that brick script, that is the reference to our brick script. And then we are going to store that in our collision. So collision dot game object dot get component, and then in the angular brackets these bricks. And then we are going to open this if statement, and in that if statement we are going to check if our bricks is not equal to null, meaning if we have in our scene bricks, and if our collisions is enabled. So collisions enabled is equal to true. So collisions enabled if our collisions enabled is equal to true. So what will happen if we have the bricks in the scene and if our collisions are enabled? So in that case we are going to call our collisions. So then we are going to pass our brick, and then we are going to call our onCollision function that we have coded previously. And then we are going to also say here that our collisions enabled is back to false, and then we are going to start our coroutine. But before that we need to create that coroutine, and we will create that just in a second. So we'll go down here of our onCollision enter function and create iEnumerator. So iEnumerator, which is our coroutine, and activate collisions. So we will name our coroutine activate collisions, and we'll open these curly brackets. We will pass here yield return, so yield return new, and then wait 4 seconds. And in the parentheses we will add a very small value like 0.01f. So this is very small value. This means immediately after we start the game, this coroutine will be executed or called. And then collisions.enable back to true, because now in this case after we start the game we want our collisions be enabled. And then, as I said, we'll call this coroutine in this onCollision. So start a coroutine and then activate collisions like this. Add one more time parentheses, and we are done. So now last method in this game is the method that we have called in the update method, and we will again create that method. So this is the private void, so simply init function like this, open the curly brackets, and in this function we are going to position the ball above our paddle and launch the ball. So we'll create that two effects. So first one effect is positioning the ball above our paddle. So transform.localPosition, local position is equal to paddle.transform.localPosition, and then we are going to add that one into another with our paddle to ball. Puddle to ball, that is our distance between our puddle and our ball. So we simply here in this line of code position our ball above our puddle, and then we are going, as I said, to create the effect of launching the ball. So we are going here in the if statement, and then we are going to pass here input.get mouse button down. So when we click left mouse button, this 0 means left mouse button. So if we click left mouse button down, we are going to use our body, so my body.velocity, and then store that in our new vector2, and then in the parentheses we are going to use our x launch force, and for the y-axis of course y launch force that we have created in the variables. And then last line will be this has started is equal to true, because we started our game. So now I will save this, guys, and I think everything is understandable and clear to you. If something is not clear or understandable to you, simply go in our comment section and ask whatever is not understandable to you. But I think everything is understandable. So here we simply created the collision between our bricks and our ball. Then we are created this activate collision in order to we can via this coroutine activate our collisions, and then when we are not going to activate our collisions, and in this init function of course we created that we want our ball be above our puddle, and then we created the launching ball effect. So when we started our game, of course we call this init in the update. And then this for example, this function doesn't require to be called because this is one of behavior function, and also this coroutine we call in that function. Okay, everything is fine. I will once again save all of this, go back to our Unity, and now of course before every testing we are going here in the ball game object and attach our ball script that we have just coded. So we see that the x launch force is 3 and y launch is 11, and that was that. If you're not satisfied with this variable value, feel free to change that. So now we will of course finally test this out and see this game in action. So we will click left mouse button, and yeah, we destroy one brick and everything is fine, but we see that these walls actually don't work. So why don't work? We'll go here in these walls, so left wall, and yeah, we didn't attach a component, we didn't attach colliders to our walls. So we need to choose all of our walls, left wall, right wall and roof wall, and attach our box collider to that. So 2D, don't touch 3D, and that was that for these walls. So when we go in one particular wall, I think this collider is attached. So no. So actually guys, we need to position these colliders on our wall. So I will do that by clicking here on the edit collider, and you see that our collider is here. So again, I will click here in the edit, so I will move here collider like there and then there, and just follow me in order to not mess up. Just joking. I'm sure that you're better than me in this work. I'm not have the patience for this work. So this kind of work I don't really have much patience. I want to do this very quickly, very fast, just in order to pass that. However, anyway, we must position these colliders on these walls in order to our ball cannot go outside of our screen, outside of our gameplay. And for the last thing, for the left, yeah, collider, we are going to do exactly the same. So actually we positioned this collider on the roof wall. We made a mistake, but anyway, we'll take this roof wall and position to the left wall. Sorry about that, but this was nothing scary. Mistake was in the naming of this collider. I got confused, and I think guys it's very fine. Okay, we attach our colliders on our walls. Now we are going to see if our ball will be able to go through these colliders. So now when I go here and release our ball, we see that, and our ball of course cannot go outside of our walls, and that was the effect that we wanted to create. But we see when our ball touch our brick, or when our ball touch our wall, our ball get very slow, and we do not want that. We want our ball have one default velocity in every case, one static velocity in any case. And for that we are going here in our assets, and we are going to right click, go to the create, and searching for the physics material, but this time 2D. So we're going to create a physics material 2D for our ball, and we'll simply name this ball material. And simply for the friction we are going to leave this as a 0. We are going to change this to be 0, and for the bounciness we are going to change this to be 1. So that was the changes in our ball physics material. So for the friction, we are not going to have any friction for our ball, but for the bounciness we will have a 1 bounciness. So actually 1 coefficient with our bounciness. Okay, now I think everything's fine. So we'll go here again in our ball, which is our player, and then we are going to attach this physics material to our rigid body slot for the material here for our physics. And now I think we will solve this gap. So I will again play this game. So now when I go here and release this, you see that everything works, guys. We can play our game as much as we want. So my PC is a little bit slow when I recording and play our game in the same time. But anyway, guys, you can play this game as much as you want. So actually we did not create the, you see, the dying effect. So actually that is because our road down here, or our border or our signboard, actually have this box collider. In order to our ball cannot touch this board and jump off of our board, we need to click here on the is trigger, and then our ball will go through this signboard. And guys, as I said, that was that for this game. Now I will save this, and until some next tutorial, guys, see you.